Good evening once again. My name is Arnold Young and welcome to Smart Modium. We've already started a lecture series on single variable calculus. We've started with limit, evaluating all forms of limit. But today I want us to go through these questions. This is actually a tutorial question, so I will try as much as possible to solve some questions with you. Some are a bit technical, some are also easy. So let's begin. So the first question is a simple one. The limit x approaches 0 of the expression 5 cos x plus 3 sine x. So here you can do your direct substitution. So as x is approaching 0, what do we end up with? We end up with 5 cos 0 plus 3 sine 0. So cos 0 is 1, so we have 5 times 1. Sine 0 is 0, so 3 times 0. We end up with 5. So our answer for this limit expression is 5. We are starting light to move on to the second question. Now the second question is the limit as x is approaching 1 of the expression x cubed minus x squared plus 2x minus 2, all on the expression x cubed plus 3x squared minus 4x. So you realize that for this particular limit expression, we have a polynomial on the numerator. We also have a polynomial on the denominator. And I've said earlier that whenever you have a limit expression such that after doing your direct substitution or applying the limit rule directly, you end up with an indeterminate form of 0 over 0, what do? There are three key things you do. One, you try as much as possible to rationalize if any of the expressions, being it on the numerator or the denominator, contains a set. If it contains a polynomial, what do? You factorize. Or if the numerator or the denominator contains a complex fraction, what do? You first simplify, evaluate the complex fraction before you can apply the limit rules. So for here, we have a polynomial on the numerator. We also have a polynomial on the denominator. So what do? We factorize. So for the numerator, it is actually simple. For the first two terms, I have x squared as a common term. So I can factorize the x squared out, leaving x minus 1. For the last two terms, I can also factorize 2 out. For the denominator, x is common throughout the three terms. So I can factorize x out first. And I will now have x squared plus 3x minus 4. Now from here, the work is actually simple. You realize for the numerator, x minus 1 is common in each term. So I can factorize the x minus 1 out. So x minus 1 in parentheses multiplying x squared plus 2 in parentheses, all on x multiplying x squared plus 3x minus 4 in parentheses. Now from here, the job is simple. The only thing for you to do is to factorize this particular expression, and it's simple. It is a quadratic, so it's actually simple. X squared multiplied by negative 4 will get negative 4x squared. Now, factors of negative 4x squared, when multiplied will give you negative 4x squared, but then when added will give you 3x. And those factors are positive 4x and x. So I can write this as the limit as x minus 1, x squared plus 2 divided by x squared plus 4x minus x minus 4 as x is approaching negative 1. So it becomes x minus 1 in parentheses, x squared plus 2 in parentheses, multiplying. Now for these, we have a common term, which is x. So you factorize x out, x plus 4 in parentheses. Now here I can factorize negative 1 out. then the job is done. So from here, what do we have? We have the limit as x is approaching 1 of the expression x minus 1 multiplying x squared plus 2 all on x multiplying. For these terms, we have x plus 4 as a common term. So we factorize x plus 4 out, leaving x minus 1 in parentheses. Realize x minus 1 can cancel x minus 1 here. We end up with the limit as x approaches 1 of the expression x squared plus 2 divided by x multiplying x plus 4 in parentheses. So from here, as x is approaching 1, what would the limit be? It would be 1 squared plus 2 divided by 1 times 1 plus 4. Then we end up with 3 divided by 5. It is actually simple. It is so simple. It is so simple. So I believe we are through with this one. I think this is the second problem, right? Yeah, we'll step it up a little bit, but not now. Let us kill all the simple questions. Now try this one also. That is question 3. The limit as x is approaching 1 of x raised to the power 4 minus 1 divided by x minus 1 is equal to the limit as x is approaching k of the expression s cubed minus k cubed divided by s squared minus k squared. Now this is a simple question. This is a simple problem. This is a simple problem. The question is, find the value of k. Find the value of k. So let us first simplify the limit on the left hand side, then we simplify the limit on the right hand side as well. So on the left hand side, so simplifying, so on the left hand side, we have the limit as x approaches 1 of x to the power 4 minus 1 on x minus 1. Now we can factorize the numerator simply. You can write the numerator as difference of two squares. So you can write that s squared all squared minus 1 squared all on x minus 1. So we get the limit as x is approaching 1 of x squared plus 1 in parentheses multiplying x squared minus 1 in parentheses all on x minus 1. We can further factorize this term. So we do that. So limit as x approaching 1 of x squared plus 1 x plus 1 x minus 1 all on x minus 1. This term cancels out this term, so we end up with the limit as x is approaching 1 of the expression x squared plus 1 x plus 1. So from here we can do a direct substitution. Then what are we going to get? So as x is approaching 1, we end up with 1 squared plus 1 multiplying 1 plus 1. So what do we get? 1 plus 1 is 2. 1 plus 1 is 2. So 2 times 2, we get 4 for the left hand side limit. Now simplifying the right hand side as well. What are we going to get? What was the right hand side limit expression? The limit of x cubed minus k cubed divided by x squared minus k squared as x is approaching k. So the limit of as x approaching k of x cubed minus k cubed divided by x squared minus k squared. This is actually simple. We'll first have to factorize this, the difference of two cubes. That would factorize the difference of two squares. So you remember from algebra, I think I said this in the last lecture, in the previous lecture. If you have something like a cube minus b cube, then to factorize it, it is written as a plus, sorry, not a plus, a minus a minus b in parentheses, a squared plus ab plus b squared in parentheses. So we substitute this expression with its corresponding factorized difference of two cubes. So s cubed minus k cubed can also be written as x minus k in parentheses, s squared plus xk plus k squared. So substituting in there. For the denominator, it is familiar to us, so we don't have any problem. So we end up with x minus k multiplying x squared plus xk plus k squared, all on x plus k multiplying x minus k. So x minus k cancels out x minus k. Then what do we have now? So as let me write it again. So the limit as x is approaching k of the expression s squared plus xk plus k squared divided by x plus k. So we substitute, so wherever we see x, we substitute in k. Wherever we see x, we substitute in k. So as x is approaching k, we end up with, that is k squared plus k squared plus k squared divided by k plus k. So we have 2k. So we end up with 3k squared divided by k, and we have 3k. Now, we know that the left-hand side limit is equal to the right-hand side. So for the left-hand side, we had 4. Now for the right-hand side, we have 3k. So we equate them. So 4 is equal to 3k, and our k is 4 on 3. This is a nice problem. This is a nice question. Now we move on. Let's say you have the expression, the limit as x is approaching 2 of s cubed minus 3x squared plus x plus 2 divided by x cubed minus x minus 3. Now we check if this is an indeterminate, and truly it will be an indeterminate. So we'll do a direct substitution to check if it is indeterminate. 2 cubed minus 2 minus 6. We end up with 0 over 0. Now, if we have this form of indeterminate, what do we then do? We check. Since our numerator and denominator both are polynomials, then we factorize completely. Now, there's one thing you should know. For the first polynomial, it is of the order, the highest degree of the variable, of the independent variable is 3. But then after substituting in x is equal to 2, we end up with 0. Then it means it can be factorized, and meaning x minus 2 is a factor. You remember whenever you have a polynomial, say f of x, right? And if this particular polynomial is to be divided by, say, x minus a, then after finding, you equate this to 0, find x is equal to a. Then after finding f of a, you end up with 0. Then it means that, meaning x minus a is a factor of the polynomial f of x. That's the meaning. So after substituting in x is equal to 2 into both polynomials on the numerator and the denominator, we end up with 0 on 0. So meaning x minus 2 is a factor of this particular expression, s cubed minus x minus 6. The same thing, x minus 2 is a factor of s cubed minus 3x squared plus x plus 2. Then we can divide the polynomial by the factor x minus 2 to get the other factors. We can also do same for the denominator to also get the other factors. So that's what we are coming to do. This is high school physics. So, high school mathematics. Now, so we do our long division. So for the expression x cubed minus 3x squared plus x plus 2, we have x cubed minus 3x squared plus x plus 2. Yes. Then our divisor is x minus 2. Now, it is simple. We already know this. Now we find a term when multiplied by, that is this particular term, right? We'll end up with a term with the degree x cubed, right? And that particular term when multiplied by this expression would end up in x cubed is x squared. So x squared, multiply x squared by x, we end up with x cubed. X squared minus 2, we end up with minus 2x squared. Simple. Now we perform the subtraction. We subtract. Now 2 minus 0 is 2. X minus 0 is also x. Now that is negative 3x squared minus 2x squared. What do we get? Meaning we have negative 3x squared minus 2x squared. What do we get? We end up with negative x squared. So negative x squared. Now x cubed and x cubed, they cancel out. So we have this. I'm coming. I'm gonna write everything again. So negative x squared. Yeah. Now, what term, right, when multiplied by the divisor, will end up in negative, at least we'll have negative x squared in that term. And that term is negative x. So if I multiply negative x by this particular expression, I get negative x squared. So negative x times negative 2, we end up with positive 2x. Then I can perform my subtraction. What do I get? I end up with 2 minus 0 is 2. X minus 2x. What do I end up with? Negative x. Then this term cancel out because you have negative x squared plus x squared. Now hope we are fine up to this point. Now again, what term when multiplied by this term will have at least negative x, and that term is negative 1. So negative 1 multiplied by x end up with negative x. Negative 1 multiplied by negative 2 end up with positive 2, and from here we get 0 0. So meaning the factors of the numerator, which is the numerator, which is x cubed minus 3x squared plus x plus 2, are x minus 2 and x squared minus x minus 1. So simple. Now, the other term, which was the denominator, x cubed minus x minus 6. So let me note this. So the other term was, that is x cubed. Let me write it again. X cubed minus x, I guess, minus x minus 6. Let me check if that is all. X cubed minus x minus 6, yes. The divisor was x minus 2. So we'll do the same thing for here. So now, what term when multiplied by this term, right, will end up in at least x cubed as a term. and that particular term is x squared. So x squared multiplied by this term, we have x cubed minus 2x squared. Then we perform the subtraction. So 6, negative 6 minus 0, we end up with negative 6. Negative x minus 0, because there's no x term here. So negative x minus 0 also end up with negative x. Now 0 minus 2x squared, because there's no x squared term here, so we assume that the coefficient of x squared, the x squared term here is 0. So 0 minus 2x squared. So 0 minus 2x squared. What are we ending up? We end up with positive 2x squared. So this is positive 2x squared, and the x cubed terms will cancel out. Now, what term when multiplied by this will at least end up with 2x squared, and that is positive 2x. So positive 2x multiplied by this term, we end up with 2x squared minus 4x. Then we perform the subtraction. So negative 6. So negative 6 minus 0 gives you negative 6. That is negative x minus 4x. What do we end up with? Positive 3x. And this goes to 0. Now, what term when multiplied by this will end up in at least the first term being part of the resultant term, and that is 3. That's a still 3 multiplied by this expression, we get 3x minus 6. And we are done. So meaning the factors of x cubed minus x minus 6 are, in the factors of x cubed minus x minus 6 are x minus 2 and x squared plus 2x plus 3. X squared plus 2x plus 3. Good. So you can now substitute in those terms there. So limit as x is approaching 0. It was approaching 2 rather, yeah. X is approaching 2. Now the numerator was this expression, so replace that with this, which is x minus 2 x squared minus x minus 1. X minus 2 x squared minus x minus 1. All on x minus 2 x squared plus 2x. Now this was 2, the limit as x approaching 2, plus 2x plus 3. So from here, the job is simple. So this can cancel this out. What do we get now? Can we perform any factorizations? Can we perform any more factorizations? No. So from here, we do our direct substitution. So the resultant limit expression is the limit as x approaching 2 of x squared minus x minus 1 divided by x squared plus 2x plus 3. So as x is approaching 2, what do we have? We have 2 squared minus 2 minus 1 divided by 2 squared plus 2 times 2 plus 3 is equal to 4 minus 2 minus 1 divided by 4 plus 4 plus 3. 4 minus 2 is 2. 2 minus 1 is 1. So 1 over 4 plus 4, 8 plus 3, 11. So we end up with 1 over 11. This is a simple question, but it's just involving. Let's move to the next one. The limit as x is approaching 0 of x plus 9 minus 3 divided by x. Now, you realize this has a radical in here. So what do we then do? So, but first, let's check if it's an indeterminate. So, you do the direct substitution. 0 plus 9 minus 3 divided by 0. Yes, the first term is 3. 3 minus 3 is 0. The 0 over 0. So, this is clearly an indeterminate. So, what do we do then if it's an indeterminate? What do we do? Since it contains a set, we rationalize. But then I also showed you another method. I substitute in some expression in place of what is under the radical to cancel out the what? The radical. Then you can simplify and apply your limit laws or rules afterwards. So let's move on to the next page. So we have the limit as x is approaching 0 of root of x plus 9 minus 3 all on x. So here we can rationalize. So let me say method 1. For the case of those who didn't watch the previous lecture, the method 1, let's rationalize. So rationalizing, we know how to rationalize from high school, right? So you multiply both the numerator and the denominator by the conjugate pair. Now we end up with the product of these two is actually the difference of two squares. So can write this as, that is root of x plus 9 all squared minus 3 squared divided by x multiplying root of x plus 9 plus 3 in parentheses. We get x approaching 0 of x plus 9 minus 9 divided by, that is x multiplying root of x plus 9 plus 3. From here we end up with the limit as x is approaching 0 of the expression x, cos 9 minus 9 is 0. So x multiplying x plus 9 plus 3. This x cancels out this x, so we end up with the limit as x is approaching 0 of 1 over the expression x plus 9 plus 3. Then the job is done. So from here, realize after doing a direct substitution, you are not going to end up with an indeterminate. And that will be our final answer for the limit. So as x is approaching 0, our expression approaches 0 plus 9 plus 3 is equal to root of 9 plus 3. And the answer is 1 over 6. This is very simple. Now for the method 2, you remember I said you substitute in some expression which will cancel out the radical. So the limit as x is approaching 0 of the expression x plus 9 minus 3 divided by x. I can say that let's say y squared be equal to x plus 9. Now if y squared is equal to x plus 9, then as x is approaching 0, then my y approaches 3. It's actually plus or minus 3, but then we take the positive root. We are not doing one-sided limits here. We talk about one-sided limit in some other lecture. We take the positive root now. So we can say the limit as y approaches 3 is, that is the root of y squared minus 3. What is x? X here will be y squared minus 9. Then we can say the limit as x approaches 3 of y minus 3 divided by y squared minus 9. We can factorize the denominator. So the limit as x approaches 3 of y minus 3 divided by, that is y plus 3, y minus 3, because this can be written as difference of two squares as y squared minus 3 squared. And we know this. This cancels out this. We end up with 1 over y plus 3. That's the limit. The limit as x is approaching 3. Now from here we end up with 1 over 3 plus 3, and our answer is 1 over 6. So interesting. Now let's try a different problem. Let me go to the simple ones. So limit as x approaches infinity of 7 minus x plus 2x squared minus 3x cubed minus 5x to the power 4 divided by 4 plus 3x minus x squared plus x cubed plus 2x to the power 4. Now there are two ways of evaluating limit to infinity. There are two ways. That is, after doing a direct substitution, you end up with infinity over infinity. This is also an indeterminate form of limit, right? But there are actually two ways of evaluating such limit. One is dividing through each term by the highest, by the term with the highest degree of the independent variable, right? So for here, we can do what? We can say the limit as x is approaching infinity of, so I'm dividing through by the highest, and that one is x to the power 4, plus x divided by, 7 divided by x to the power 4 minus x divided by x to the power 4. Let me do it, which is x divided by x to the power 4, which is 1 over x cubed plus 2x squared divided by x to the power 4, which is 2 over x squared minus 3x cubed divided by x to the power 4, which is 3 over x, minus 5x to the power 4 divided by x to the power 4, which is negative 5. All over. The same thing applies to here. Dividing through by the highest power, we end up with, here will be squared, here will be, let me see, the first term will be cube, sorry, supposed to be cube, then x squared divided by, which will be 1 over x squared, then plus, that is x cubed divided by x to the power 4, which will be 1 over x, plus here becomes 2 because 2x to the power 4 divided by x to the power 4. So now the job becomes simple. So as x is approaching a larger value, infinity, now this term will approach 0. 7 divided by a large value approaches 0. So I can say 0 minus 0 plus 0 minus 0 minus 5 for the numerator. Now for the denominator, the same thing applies. So here becomes 0 plus 0 minus 0 plus 0 plus 2. So our answer is negative 5 on 2. Simple. Or I won't solve this. Or you can say, you can say let x be equal to 1 over 5, 1 over y, sorry. So you're introducing a new variable. Now you substitute in 1 over y for x. Then you also find the new limit for the expression containing the y terms. So x is equal to 1 over y. So as x approaches infinity, what will be y? Y will approach 0. It is clear. 1 over a large value. This will be y is equal to 1 over x. So 1 over a large value will give me 0. That's it. So I substitute in 1 over y for x expression. That is simple. I'm not going to do this. Time is fast spent. But then that's another method of solving the limit, the indeterminate limit, infinity over infinity. That's the limit to infinity. That's another way of solving it. So I can call this method 2. That is it. Now let's move to the next interesting problem. Now this problem is so interesting. If you really understand the limit, I believe you should be able to solve this problem. So x squared plus x plus 1 divided by x plus 1 minus ax minus b is equal to 4. Now, the question says we should find the values of a and b. So find the values of A and B. How was it done? Let us first simplify. Then after we find the values of A and B. So simplify. So the limit as x is approaching infinity of x squared plus x plus 1. The LCM for here and then here, this term is x plus 1. So if x plus 1 is the LCM, then I can say ax plus b in parentheses all on x plus 1. Oh, sorry, I'm coming. X plus 1. Yeah, so from here I can solve it. So the limit as x approaches infinity of x squared plus x. Then since the LCM is x plus 1, multiply this term by x plus 1. So ax plus, that is b, multiplying x plus 1 all on x plus 1. Because the LCM is x plus 1, right? This is divided by 1. So if the LCM is x plus 1, x plus 1 divides x plus 1 how many times? 1. Multiply it by this, you end up with this expression here. Now 1 divides x plus 1 how many times? X plus 1 times. So you multiply this expression by x plus 1. That is what I've done here. Now let us expand, then continue. So expanding, what do we get? We get the limit as x is approaching infinity of x squared plus x plus 1 minus, now here becomes ax squared plus ax plus bx plus b all on x plus 1. What do we get afterwards? We get the limit as x is approaching infinity of x squared plus x plus 1 minus ax squared minus ax minus bx minus b divided by x plus 1. Now, I want to do one thing. I want to group like terms, and you'll get to know the reason why. So I'll group like terms. So I'm grouping all the x's, all the s squares, and then the constant separately. So the limit as x is approaching infinity of, now the s squared terms are these, this one and this one. So I can say 1 minus a x squared. Now for the x terms, I have x here, another negative x here, negative ax, sorry, negative bx here. Then I can say 1 minus a minus b times x. The constant terms, what do I have? For the constant, I have 1 and negative b. 1 and negative b. So for the constant, I have 1 and negative b, all divided by x plus 1. Now you remember I showed you something from limit. That is when you have the limit of, say, some particular function, right? As x is approaching infinity. Let's say you have ax squared plus b divided by, that is divided by x plus 1. You realize the numerator, that is for the numerator, the highest degree of the independent variable is 2. So the degree on the independent variable is greater than, that is for the numerator is greater than that on the denominator, because for the denominator we have x to the power 1. For the numerator I have x to the power 2. Right? So all the time I show you that if you have such a limit expression form, this particular limit will be what? This particular limit will approach, you remember I said it, will approach what? Will approach infinity. I said this will approach infinity. So this particular limit will approach infinity. Now, I also said that, oh, I'm sorry. Now, I also said one thing. I said that if you have the limit of some expression as x is approaching infinity, such that say x squared plus b divided by cs squared plus c. Now I realize for the numerator, that's the highest degree of the independent variable is 2. That is, the highest power of the independent variable on the denominator as well is 2. Then for such limit, we get, what do we get? We get a constant. I said it the other time. What do we get? We get a constant. I said it, and all the time the constant is, that is, a over c. That for the numerator will be the coefficient of what? The highest power of what? X. For the denominator, the same thing. Yeah, so that's the idea we are coming to use. And for us to get a constant, because we've already been told that the limit is equal to 4, right? So meaning that is, the highest power on the denominator should be the same as the highest power on the what? On the numerator. But then we have x squared here. So meaning this particular term should go to 0. That's the meaning. That particular term should go to 0. So I can say that is 1 minus a is equal to 0. The coefficient of x squared is 0. Then a is equal to 1 from here. Then from here, since the greatest power on the denominator is 1, then you check through. Okay, meaning, as I said earlier, if the greatest power on the numerator is s squared and the greatest power on the denominator is also the s squared, I mean, they both have the same powers, then the limit will be what? That is the coefficient of the greatest power of x divided by the coefficient of the greatest power of x on the denominator as well. So the same thing applies here. If this particular term is 0, then what will be the limit? What will be the limit? The limit will be 1 minus a minus b, which is the coefficient of the greatest term here. If our limit is surely a constant, then the coefficient of the greatest term here divided by the coefficient of the greatest term here, which is 1 in this case. It is so simple, which is 1 in this case. So let us do that. So what are we going to get? We are going to get 1 minus a minus b is equal to 4. A is equal to 1. Then we can find b. If a is equal to 1, then 1 minus 1 minus b is equal to 4. 1 minus 1 is 0. Negative b is equal to 4. We end up with negative 4. Negative b is equal to 4. We end up with b is equal to negative 4. So the values of a and b is 1 and negative 4. 1 and negative 4. Yeah, these are interesting questions. Some are a bit technical, but I believe you've grasped the concept. I believe you have the concept. Now let us solve one last question, then we call it a day. Then we continue in the next lecture. Now let's say you have the limit as x is approaching infinity of the expression 5x raised to the power 10 plus 3x raised to the power 1 or raised to the power 3 divided by 1 minus 2x raised to the power 6 or raised to the power 5. This is so simple. Now, I'll just do algebraic manipulations, right? What do I mean by algebraic manipulation? For the term in the bracket, I can factorize out an x term, which will be the same as a term factorized, an x term here factorized out, such that the x term here cancels out the x term here. Then I can do the direct substitution for x, substituting in x with infinity. So let me demonstrate what I'm trying to communicate. Now the limit axis approaching infinity, this is what I can do. I'll factorize out x to the power 10. Factorizing out x to the power 10, I'll end up with, that is 5 plus 3x divided by x to the power 10 all raised to the power 3. for the numerator. For the denominator, I can also factorize out x to the power 6 here. So x to the power 6, I end up with 1 over x to the power 6 minus 2, all raised to the power 5. Then what am I going to get? You realize that 3 can multiply, that is the power on the x. So I end up with the limit as x is approaching infinity of let me separate it, of x to the power 30 multiplying 5 plus 3 on x to the power 9. The same applies to here, 6 times 5 x to the power 30 multiplying 1 over x to the power 6 minus 2. So the work is done. X to the power 30 cancels out x to the power 30. So I have limit as x approaches infinity of the expression 5 plus 3 divided by x to the power 9 divided by, that is 1 minus 1 minus, let me see. Yeah, I mean 1 over, sorry, let me erase it. So 1 over x to the power 6 minus 2. As simple as that. So this raised to the power, this was raised to the power 10, I guess. No, 3. Yeah, 3. Let's raised to the power 3. This was raised to the power 5. So it is simple. As x is approaching infinity, what are we going to get? As x approaching infinity, then our 3 divided by x to the power 9 will approach 0. And 1 divided by x to the power 6 will also approach 0. Then I can substitute in those limit values. So I end up with 5 plus 0 divided by 0 minus 2. So my answer will be negative 5 on 2. And that's my final answer for the limit. Now I'll end the class here. In the next lecture, we'll try to solve more problems on limit. Then I think I will close the chapter on limit with you, or probably come back with some technical questions. Then afterwards, we'll close the chapter on limit. But then as time goes on, I'll prepare separate lectures on one-sided limits and probably continuity. Yeah, have a wonderful evening.